Okay, so let's talk about margin of error now. In our previous lecture, I talked about confidence interval. We actually saw a couple of examples of constructing confidence intervals. Now, the question might be, how reliable, if you will, how reliable is this confidence interval that we have constructed? How good is it? So the question that needs to be addressed is, how precise is our estimator now? Okay, and we're talking about again our estimator X bar in this week. Next week we're going to talk about different estimators. So the answer to how precise is the estimator is to look at the margin of error of X bar. So what is the margin of error? The margin of error tells us the maximum error that we can commit when we use X bar to estimate the population mean mu. Okay. Now it's going to be based on the confidence level, of course, because that's what determines the margin of error, is the confidence level directly. But that's what that is. So for example, let's say I get a sample, whatever size, and I say the average rent is $2,000 in a given location. And my margin of error is $200. So that means that estimate of $2,000 for the true average mean mu of all rental units in that location is off by no more than $200. And that's what that margin of error means. Okay. Now, how do we actually find this margin of error? We can actually look at the formula for confidence interval. And this formula is, there you go, sorry. I'm up here. Okay, so the formula was X bar plus minus the alpha over 2 sigma over root n, which this part is what we call the margin of error. What's to the right of plus minus? That's margin of error. Okay, so I went in and wrote it. ME, margin of error, is E, Z alpha over 2 times sigma over root n. Now, just like the length of the confidence intervals, we can see what affects the precision here. As your error increases, your precision drops. As your error decreases, your precision goes higher, means you're more accurate. Okay, actually, yep. There's technical difference between accuracy and precision, but anyway, means your estimate is more precise. Okay. That means the variability is actually lower in your estimation. That's what precision is. Think of precision as variability. Okay, and so what we have next is in this little thing I have on the side, and I'm right over here, folks. Where's my pen? I'm over there. Sorry, I'm now over here talking about this. Okay. So if you think about the length of the confidence interval is stretching from X bar, the center, out to X bar plus margin of error, X bar minus margin of error E, then the whole length of the confidence interval is L, which is made up of 2 E's. Okay. And that's because, again, we have one E above the center, right? We have an E here, and then we have an E directly below it. Okay, so 2E, 2 times the margin of error, is what the length of the confidence interval is. So if, for example, in Minitab it gives you the confidence interval, you can find the length of the interval by subtracting the lower limit from the upper limit, divided by 2, and you get your margin of error. Okay, so that actually comes in really handy. And so just want to point that out also. Okay. Now, again, we can improve the precision of our estimators by increasing the sample size or reducing variability. Now, the last question in this segment is, okay, well, if I actually want to conduct the experiment, I want to estimate the mean. I want to know what is the average PE ratio for a technology stock in a given sector. Let's say it could be semis. What is the true average PE ratio. In order to estimate that true average, well, how many companies do I need to survey? So what should my sample size be? And that's what we want to answer. How large a sample do I need in order to estimate mu? So the answer lies with the margin of error. So remember, this is a formula for margin of error. So what I've done here in the next 1, 2, 3 steps, I've actually solved for n. These are a few algebraic steps. If you follow them, great. If not, don't worry about it. We just want that n formula. But just to explain what I've done, I multiplied both sides by square root of n. Then I squared both sides to get rid of the radical. Then I divided both sides by e squared. And then because to the right, z, sigma are both squared, dividing by e squared, I put z sigma over e in parentheses, the whole thing squared. And there you go. And that's going to give you the formula for the sample size. So now, one thing to note for sample size, by the way, we always round up regardless of the trailing decimal. So for example, the sample size in the formula may come out to be 97.1 and we round it up to 98. You'll see an example in a minute. Because it's better to have a whole, we cannot have portion of a person. And to be conservative, we always round up, which makes the margin of error just ever slightly smaller. Okay, so for example, I have, what if the formula gives me sample size to be 23.15? Well, we're going to round up to 24. You see that 0.15? Usually in math classes, we say round it to 23, right? The nearest whole number, but not in statistics. They always round them up. If the sample size is 18.76, well, this naturally rounds up to 19, right? But regardless, again, regardless of the decimal to the right, you always round up. So here is an example of working with sample size. Question: how large a sample do we need to estimate the population mean? We want to be 95% confident in our estimate with a margin of error no more than 30. And we're going to assume sigma 190. I'm just making up these numbers. So let's put the specifics into this. The fact that the confidence level is 95% right in here, that means alpha is 5%, half of that 2.5%. Remember, z of 0.25 is 1.96. I had that earlier in the previous lecture. And I went ahead and plugged in a z of 0.25, 1.96 here. Sigma was 190. The margin of error was 30. Use a calculator, square it, and this is what you get. And you always round up. Notice, by the way, 154.09, how close that is to 154. We still round it up. Okay. And there you have it. So hopefully this explains the margin of error for you. And with that, we are done with this segment of this video. Our next video, we actually talk about hypothesis testing.